and welcome viewers. In today's lecture, we are going to study fixed bias of a transistor. Before we delve right into the context of fixed bias or base bias, let us first discuss what transistor biasing is in a nutshell. Transistors are one of the most largely used semiconductor devices, which are utilized for a variety of applications that includes amplification and switching. To achieve these functions, the transistor is supplied with a certain amount of current and voltage. This is known as transistor biasing. This can be accomplished by a variety of techniques, resulting in different kinds of biasing circuits. The main principle includes providing the right amount of base current IB and in turn the collector current IC form the supply voltage VCC when there is no signal present in the input. The collector resistor RC is chosen in such a way that the collector emitter voltage VCE is significantly higher than 0.5 volts in case of germanium material transistor and 1 volt for silicon material transistor. There are many techniques of biasing. However, here we will mainly focus on fixed or base bias of transistor. Fixed base bias or fixed resistance bias. This form of biasing is also called base bias. The biasing circuit shown in the given figure has a base resistor RB linked across the base and VCC. The emitter junction of transistor is forward biased by a voltage drop across RB which results in IB flowing through it. The mathematical expression for IB is obtained as. Here, the values of VCC and VBE are fixed while the value of RB is constant on designing the circuit. This leads to a constant value of IB across the circuit resulting in a fixed operating point or Q point due to which the circuit is named as fixed base bias. This results in a high stability factor of beta plus 1 because IB is constant. So, DIB by DIC is equal to 0, which leads to very poor thermal stability and leads to thermal runaway. Let us apply KVL in base emitter loop. Now applying KVL in the collector emitter loop. Now let us discuss the advantages and disadvantages of the fixed biasing of a transistor. Advantages. Operating point can be shifted easily anywhere in the active region by merely changing the base resistor RB. A very small number of components are required. Disadvantages. Poor stabilization. High stability factor, that is S is equal to beta plus 1, hence prone to thermal runaway. In today's lecture, we have learned transistor biasing and its need, fixed or base bias of a transistor, advantages and disadvantages of fixed bias of a transistor. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.